Hello guys, you are welcome to Extra Lesson TV. Today we are going to talk about bending energy. Bending energy is the energy released in the formation of nucleus from its constituent nucleon. So bending energy is represented as kinetic energy, and it is represented by instant formula, that is it is represented by this formula, where E is in joule and M is a mass defect, that is change in mass, which is measured in kilogram, and also C is speed of light, that is constant, 3.0 exponential 8 meter per second. Yes, as it is squared in our formula, so let's put the square here. So that is the instant formula. So first of all is 1 AMU is equivalent to 1.6 exponential negative 27 kilogram, and proton is equivalent to 1.0078 AMU, while the neutron is also equivalent to 1.0087 AMU. So where AMU is also equivalent to atomic mass unit, and also P is equivalent to proton, where P is equivalent to proton and N is a neutron. So those are the constants. Those are the constants that you must know before you work an example. So we must know these constants before we can successfully work an example under bending energy. So let's go directly and work at least one example so that everybody will understand how to work bending energy, so how to do an exercise and whatsoever. So let's move ahead. So this is how the question is given. You will be asked to calculate the bending energy of this atom. So here we are having sulfur as our atom of element. So here is our constant value given in the question. That is the atomic mass unit of this sulfur in this question. So first of all, when you write solution, after you bring down your question, then $35.9670 AMU. Here is our question. So first of all, you need to memorize and master those constants. Why? Because you must first add the proton and neutron of each and every element given to you. So therefore here we are having our P as 16, as everybody knows, and our N to be equals to 36 minus 16, which is equivalent to 20. So our neutron here is 20. So therefore we are going to add them, we are going to multiply them with their constant and add them together. So you have to multiply this proton by its constant value and also this neutron by its constant value, then add them together or sum them together. So here is our proton and neutron, and we have already known that our proton is equals to 16 and our neutron is 20. So definitely you are going to say 16 multiplied by 1.0078 AMU. Yes, as you have already known that this is the constant of proton. So we are to add our neutron. Then we are to say 20 multiplied by 1.0087 AMU. Then when you multiply this by this and also multiply this by this and sum them together, you are going to get something of this nature: 16.1248 AMU plus 20.174 AMU. So here is what you are going to get. As we have cleared the bracket, you all know it. Then you are to add them together or sum them together. Yes, after summing them, you are going to have something of this nature: 36.2988 AMU. So here is what we are going to get. So remember, you are to subtract this value out of the constant given in the question, mind you. So we are going to say 36.2988 AMU minus 35 point 96709 AMU. So this we are given in our question as our constant atomic mass unit. So mind you, in this point, your calculated mass must be greater than the actual mass given in the question, so that if you subtract this out of this, you cannot get negative answer. It must not give you negative answer. Whenever you subtract this out of this, the actual value out of the calculated value, and definitely you got negative answer, so you must restart your work. So we are subtracting 35.96709 AMU out of 36.2988 AMU. So definitely you are going to have something of this nature: 0.33171 AMU. So here you have gotten your atomic mass unit. But mind you, our mass defect is calculated in kilogram, that is kg. So whenever you are working, you must convert this AMU to kg. Yes, here we are converting our AMU to kilogram. 1 AMU is equivalent or is equal to 1.6 exponential negative 27 kg, and here is our calculated mass in AMU that we wanted to convert it to kilogram. So we put the x ahead of it so that we can cross multiply our work. If you cross multiply it, then definitely x is going to be 5.307336 exponential negative 28 kilogram. So here is our x in kilogram. So this is called into this equation, so that you will find the value of e. As we have now calculated the value of this m and we convert it to kilogram, so you have already known that you cannot give your answer in any unit rather than kilogram. So we are to say E is equal to 5.30736 exponential negative 28. Then you have to open the bracket and put the c, speed of light, which is 3.0 exponential 8. Then you put the square. Don't forget to put the square, as it is having square in our formula. So definitely you are going to have something of this nature. Then multiplied by 9.0 exponential 16, meter per second. If you multiply this 3 by this 2, you're gonna have this one, and if you multiply this by 2, then definitely you are having this. So what remains is to multiply them as they are in this. So now we have just break them into the consumable form. So therefore, if you multiply them here, you are going to have something of this nature. E is going to be equal to 4.776624 exponential negative 11 joule. Don't forget, as I have told you earlier, C, that's E, is calculated or is measured in joule. So don't forget to, or don't be confused. So this is how to work an example under bonding energy. Yes, under bonding energy using instant formula. Using this formula. I hope and I wish everybody understand how we take this work step by step right from the beginning to end. And I am going to summarize the constants. Yes, we are going to give you the constants of this one, and also you can try it and work. So thank you for watching.